be finding the asymptotes of rational equations like these, and really asymptotes are really just a value that any equation, that value won't work. You can get as close as you can, but it won't. So anyways, there are vertical and horizontal asymptotes, and there's also things called holes, and holes are things where you can cancel both of them from the top and the bottom out. Those are holes. And over here, I factored them out, x minus 2 and 3x plus 1, x minus 2 times 2x minus 3, just to show you those are the factored form. You'd most ideally like to keep them in the regular form, but just watch out for holes, so it's good to write them out to the side. So anyways, let's look at the vertical asymptote first, and let's start on this. So vertical asymptote, you just set this equal to 0, and you see what values can make it equal to 0. So over here you see it has power of 3, so we have to use SOAP. And 2x minus 1 is all just SOAP. 4x squared, same, opposite, always positive. And you see here, I'm just going to tell you now, this, you cannot factor it. So there's no solutions to it or anything. So there's no point having this, because if you can't plug anything in for this to get 0, then that means there's no asymptote as far as this goes. But here, 2x minus 1, you can set that equal to 0. And then if you get 2x minus 1 equals 0, you get an asymptote of x equals 1 over 2. So there's your one vertical asymptote for this equation. And you can see if you plug in 1/2 here, and then you plug it in, then you get 0. And you cannot divide anything by 0, so that's a vertical asymptote, or else it's going to be undefined. And now, look here, we got 2x minus 1 times blah, blah, blah. You can't factor that out. And none of these cancel out, so that means there's no hole here in this place. And now we have to move on to the horizontal asymptote. In horizontal asymptote, you look at the highest degree for each one. So over here, you got a highest degree of 2 for the numerator and 3 for the denominator. Well, whenever it comes to this, the rule is, if the denominator's highest degree is higher than the numerator's highest degree, then the horizontal asymptote will always be 0. Now, there are other cases, like what if the numerator is greater than the denominator, which is what we're going to get onto right here. So here's the next equation. And let's first find out the vertical asymptote, because it looks easy. You just set the denominator equal to 0. And then you see, whoa, x minus 3 equals 0, boom. Vertical asymptote, x equals 3. Easy peasy, right? That's your vertical asymptote. And now, let's go into horizontal asymptote. Well, if you go into horizontal asymptote, and then you see, whoa, wait a minute. Let's see, highest degree, this has a degree of 1, and then this has a degree of 2. So the numerator now has the higher degree. So what do we do in this case? Well, you have to divide the denominator by the numerator, or the numerator by the denominator. So how to do that? Well, we see here the highest degree is 2, so we can just use synthetic division in this case. So let's just do that. So you see, you just put the coefficients, -7 and 6. Bring the L out, x minus 3, set that to equal to 0, and then you get 3. Now you just bring down 2, 6, -7 plus 6, -1, -3, 3. So in this case, it simplifies when you divide those two to 2x minus 1 plus 3 over the x minus 3, since that's 3. So whenever you're looking at, so basically whenever the highest degree is on the numerator, then you get a slant asymptote, which is what this is. When you divide the two, you get this. So don't mind the remainder whenever you divide them. Just look at the actual numbers, 2x minus 1. And that's what it is. That is your slant asymptote. And slant asymptote is what you get and what you have to do if the highest degree is higher on the numerator than the denominator. Here's another, and then I'm gonna put on another example of what do we do in another note though. Look at the factors. We always have to watch out for holes. In this case, we don't have any holes, but x minus 2, 2x minus 3, x minus 3, you see, none of them cancel out, so there's no holes here. So anyways, let's go on to the third example. Here's the third problem that I came up with, and this is just to show. So first of all, let's work on the vertical asymptotes. You don't have to simplify or factor these out anymore. You can clearly see that they don't cancel out, so there's no holes. So vertical asymptote, you set the denominator equal to 0. -2 and -2 over 3 is your vertical asymptote. Pretty simple. And then, now, we have to look at the highest degree from the numerator and denominator. Which one's higher? Oh wait, they're both the same. So what do we do in this case when the highest degree on both the numerator and denominator are the same? We just find the fraction or the ratio that their leading coefficients create. So in this case, let's see, x to the first, what's in front of them? 2 over 3. So in this case, our horizontal asymptote would be 2 over 3. Now let's say in another case, it's like 3x to the 4th over 7x to the 4th or something, blah, blah, blah. Then over here, since they're the same, the highest, then it would be 3 over 7 as your y-intercept. But in this case, over here, since it's 2 and 3 as leading coefficients, the y and the horizontal asymptote is 2 over 3. And the vertical asymptote, -2 over 3. So, that was how you find the asymptotes, the vertical, horizontal asymptotes. Make sure to watch out for holes and stuff. There weren't any in these, but yeah, there's 3 cases. And for vertical asymptotes, you just set the bottom equal to 0, and then you see what makes any one of those 0. Like in this case, if you plug in 1/2 here, that equals 0, and 0 times this is going to equal 0, and then you can't have anything divisible by 0. That's why there's vertical asymptotes, or else it would be undefined. And for horizontal asymptotes, you just look at the highest degree. If it's higher on the numerator than the denominator, then there's a slant asymptote. If it's higher on the denominator, then the y-asymptote is just 0. If they're equal, then just take the ratio or fraction of the leading coefficients of those highest degrees, and boom, easy. And that was how you find asymptotes with Druva, and yeah, see you soon.